Hi friends, in this tutorial we are going to discuss about the procedure, serial dilution procedure in detail. It's a method of diluting a stock solution where concentration decreases by the same quantity in each step. And this is a key. The decrease in concentration is in the same quantity in each successive step. And suppose this is a stock solution and we are going to make a 10 raised to minus 4 diluted solution of the stock solution. First of all, take 4 test tubes. Label the test tubes A, B, C and D. Add 9 ml of distilled water to all of these test tubes. Transfer 1 ml of stock solution, pipette out 1 ml from the stock solution and transfer that to test tube labeled A. Here we are diluting 1 ml of stock solution with 9 ml of distilled water, making 1/10 dilution or 0.1 dilution or 10 raised to minus 1 dilution. So now we have 10 raised to minus 1 dilution. Mix well. Transfer 1 ml from test tube A to test tube B. We are further diluting by 10 times, making it in the test tube B the concentration will be 1/100 dilution, that is 10 raised to minus 2 dilution. The procedure is repeated in the case of test tube C. Mix well and transfer 1 ml of solution from test tube B to C, so that we are getting 1/1000 dilution or 10 raised to minus 3 dilution. Mix well and transfer 1 ml from test tube C to test tube D and we'll be getting 1/10,000 dilution or 10 raised to minus 4 dilution. So in each step we have diluted the stock solution 10 times, making it 1/10,000 at the end. And this is especially in the case of bacterial culture. If we want to prepare a plate method or a streak method, we need to dilute the stock solution. This is a procedure of choice so that we'll be getting minimum number of colonies in the plates. Hope things are clear. Thank you so much for watching. You are with biologyexamsforyou.com.
Okay, welcome to the 6th video on clinical reasoning, and this one is about sensitivity, specificity, and predictive values. So we're going to talk now about testing for disease. So let's say we have a population here of, or a sample of 10 patients, all right, and some of them have a disease. We don't know which ones have the disease, and the diseased ones here are marked with orange heads. Okay, and so the prevalence of disease in this population, we'll learn about prevalence in your evidence-based medicine course, but is 4/10. 4 of them have disease out of 10, so 40%. And we also have a test that can test the disease, and the test is either going to be positive, hopefully if they have the disease, and negative if they don't have the disease. And so a perfect test would do just that. Whenever the patient has a disease, the test is positive, as in these cases. And when the test is negative, they don't have the disease. However, there is no such thing as a perfect test. There's always going to be problems with that. So you can see here's a person who has a disease and the test came out negative, and here's a person who does not have the disease and the test came back positive. So when you have a patient who has the disease and the test is positive, this positive is called a true positive because it's true because the patient actually does have the disease. And when a test is negative and the patient doesn't have the disease, that negative there is a true negative because the patient truly does not have the disease. But that leaves these two cases here, these two mistakes, as you might say, and these are false. So this is negative, but it's falsely so, right? Because the patient has a disease. And this test was positive, but it's falsely so because this patient does not have the disease. So you can have a perfectly bad test, right? Like if it was completely the wrong way, but of course that as well is never going to happen. And so how do we measure the quality of a test? So how do we measure how many times it comes back falsely positive or negative and truly positive or negative? That's when we are going to use this 2x2 table to figure that out. And so the 2x2 table has on one side, and traditionally on this on the left side we have the results of a test. So you can see here's our test tube and there's a positive and negative, and then on the top you have the patient, and so whether they have the disease or whether they are healthy. And so we said, look, if the test is positive and they have the disease, that's considered a true positive. And then if the test is negative and they are healthy, that is considered a true negative. When the test is positive and they're diseased, I think I said healthy, but when they're diseased, that's considered a true positive. And again, similarly, we can put false negative and false positives in here too. And so if you add up the true positives and the false positives, that's all the times that this was positive. And if you add up all the false negatives and the true negatives, that's all the times that the test was negative. And similarly, you can add up all the healthy patients and all the diseased patients, right? And that's the true positives and the false negatives for the diseased, and the false positives and the true negatives for the healthy patients. So how often does a positive test pick up a patient with the disease? That's what we want to know. So how often does a positive test pick up a patient with a disease? And so that is, how sensitive is a test at picking up disease? And the way we calculate that is by looking at a positive test, right here, true positives, and how often does it pick up the patients with the disease? Well, it picked up the true positives, and how many did it miss? It missed the false negatives. So it's the true positives over all of the diseased patients. That's the sensitivity. How often does a negative test pick up a patient without the disease? So these are all the patients without the disease. And how often does this negative test pick up the patients without the disease? Well, that's the same thing as asking, how specific is a test at isolating a disease? And so it's the same thing right here, right? We take the true negatives over all the patients who are healthy. So true negatives over all the patients who are healthy. And so you get, that's called specificity. It's a how often is a disease, how often is a diseased person picked?
Antigens are macromolecules, usually of molecular weight greater than 10,000, such as proteins and polysaccharides. They are recognized by the immune system as foreign. Individual antibodies are not made against the entire antigen molecule, but rather to particular chemical groups on the molecules known as antigenic determinants or epitopes. Many different antibodies can be made against a single antigen, each antibody reacting with a different epitope. Complex structures, such as the surfaces of bacterial cells, may have many different epitopes. Each different antibody binds only to the correct epitope.